My name is Avik Wadifkar, and I'm a ninth grader at the Audi International School. And I'd first like to say thanks for letting me speak here. It's a great opportunity. And so today I'm going to be talking about the software called Universe Sandbox. And Universe Sandbox is essentially what it's called. It's a sandbox in which you play with anything you want in the universe. You want to know how the sun dies? You can do that. You want to know what Earth looks like when it blows up? You can do that. Universe Sandbox was initially released in 2008 just as a pet project of someone who wanted to mess with gravity and Newtonian physics, but eventually he realized that it could be used for a lot more, and not just for theoretical physicists in the boring studies that you see every day. I'm not saying that studies are all boring. I'm just saying that some people may want to do more than reading an 80-page manuscript on how the sun may look in 100 million years. And so it was initially released at 2008, and then the version seen now was released in 2012. And it's of course what's known as a sandbox game, meaning you're given these objects and these interactions, and you do what you can with those objects. And it is found on the collection of apps called Steam, and the price ranges from anywhere from $20 to $30, because it's usually $30, but there are so many sales that it's somewhere around $25 most of the time. I myself got it for $25. And the point of the software, at least the creator, Giant Army, says, is to create creating an educational physics-based astronomy software that helps by standing on the shoulders of giants, meaning that they build on the work laid there before them, which quote was taken from their mentor, Newton, or not mentor. And so some of the things that it can do are, at its most basic, it simulates gravity. It simulates collisions between different objects, collisions between celestial bodies. You can create supernovae in the middle of our solar system, supernovae anywhere. You can try and terraform planets and see what Mars would look like if you added a few 100 million tons of water to it. And you could do anything else in between. And today I'm going to be looking at a few scenarios. The first one will be the solar system, and just see how this software looks at the solar system. And so this is how the software sees the solar system. In the bottom left, there's a timestamp, and you can play around with time as well, but for now I synced it up to about this moment. And if you try and zoom in on Earth, this is what it looks like at this very moment. If you put it right over where Houston would be, and go down to the surface, you could see what the night sky is supposed to be like. I mean, not with all these stars, but you could see where the relative positions of Uranus, Vesta, Chiron, and I'm not sure if you can see any other planets at this moment. But if you unpause, you can see how the night sky might just change. And this will all happen in the future. And if you speed the timescale up to even faster and faster time steps, then you can eventually see the entire solar system moving, and you can see how everything interacts with each other. Of course, nothing really exciting happens like the collisions, but we'll get to that later.
That's good.
And so the second scenario I thought about talking about was pulsars. And now this software can surprisingly model how these pulsars are supposed to look. Pulsars are what some stars may become after they die. They're just really heavy magnetic rocks. And to make them, you just add in pretty much any star to anywhere in the software. And then in each of these, you can go into and see the star's properties, what their mass is, what what they're supposed to be made of, how hot they are, and you can change any one of them. But for us, we really just want to look at composition, and then scroll down to the, okay. And then scroll down to the magnetic field. Right now the magnetic field is 0, but the point of a pulsar is that it's incredibly magnetic, and so if we just shift this up a lot, so that's about 100 million Tesla, and then zoom out, we see this ring of concentrated material, which is what usually happens if a star becomes magnetic enough. Now this in of itself isn't enough to make it necessarily a pulsar, as pulsars pulse. And to do that, what you would, pulsars spin incredibly fast, and so if we slow this down and make the rotation speed of this faster, let's do, if we make it about 5 times a second, okay, blow it up. And this software figures out how a supernova might look of any given star. So if you try this again, it might give you a different one based on randomizing some things. But it's also just a way for your computer to look really pretty. And so the third scenario is galaxies colliding. Now, some of you may know that in about 4.5 billion years, our Milky Way and the nearby Andromeda galaxy will collide. Of course, the grandchildren of the great-grandchildren of the babies of today will be long gone by then, but it's just interesting to see what this might somehow turn out. And someday our distant ancestors might actually see this. The bottom one is our Milky Way, and the top one is the Andromeda Galaxy. The Andromeda Galaxy is quite a bit bigger, but eventually if we speed this up, they collide. And of course, none of the stars in them will actually hit each other, as there's enough empty space in between them. But they may turn into a whole new galaxy, they may just disperse out like this. We really aren't sure what will happen. But most simulations say that they'll just turn into one bigger galaxy, while the majority of the material is just sent off flying into space. And now, the fourth scenario is just about more stars. And this software has a huge collection of astronomical bodies. For example, it has a few hundred, maybe, it has actually 20 stars. It has a few, well, it has all the planets in our solar system and any planets and a lot of exoplanets as well. It has moons, it has asteroids, it has everyday objects. It has galaxies, and it also has some black holes as well. Now, while some these black holes may not do much, they do have that cool light dispersing effect that makes them look so neat. And at this point, I'm inclined to take any audience requests. So, is there anything you want to blow up, collide?
What about a moon of Saturn interacting with the rings?
All right, so we go over to here, add Saturn along with all its moons. And if we just add Saturn's rings back on, while it's a little harder to see what the effect is now, we could speed it up by either turning the gravity up, which is one thing you could do, or just get a heavier body. And in fact, one of the main points of this thing is how it shows rings interacting with different objects. If you take something heavier like Neptune and then place it a little near, okay, well, it disappeared. But if we try that again, that's one thing to do.
Sorry.
Congratulations, Bill. You turned Saturn blue.
You really made a mess of the rings.
Oh wow, now Saturn's injecting mass.
Got rid of a couple of the possible
Well,
moons out.
rings are gone and so are the moons, but it looks pretty. Anything else?
Question.
Yes.
Since the universe is fairly dynamic, how often is this program updated? Do you have any idea?
Well, they recently added a few more objects, like a sword for some reason, and they also added the recent Tesla Roadster, which the billionaire Musk sent into space. So you can add, you can go into here, these everyday objects, grab one, let's see, where is it? Grab a Tesla Roadster and launch it at Saturn at, let's say, but you could potentially launch any object at any speed you wanted. The software might not work how it's supposed to due to you breaking, the laws of physics, but it can still work sometimes. Yes.
I have two things. One, here's a story. Me and one of my friends were messing around with the simulation, and he ended up making like an 8-sided dice larger than the Milky Way galaxy and the universe itself. And second thing is a question. Do they have any option to add open clusters or globular clusters?
I do not know if they've added nebula yet. I don't think the software is good enough for the, actually, maybe they have. No nebula, just some small galaxies, unfortunately. Anything else? Yes.
I was going to ask you, sorry we came from presentation, but first of all, this is super cool.
Thank you.
What you got going here. But I was discussing next to someone before, we're talking about being able to just go supernova and everything. And I was just wondering what the impact of that would be if something so far away, just the impact on its surroundings, and if you've got even, if your program goes out that far even.
Well, one thing you could do is potentially blow up the sun and see what it looks like in our solar system today. So if you just take, our regular solar system, and let's see, tools, so blow up the sun, and focus on, whoops, I accidentally blew up Earth. But the thing is, supernova, as they immediately turn into planetary nebula or clusters, instantly engulf whatever of our solar system may be around. And of course, our sun wouldn't do that, as it doesn't have the energy necessary. It just turned into a red giant, expand until about Mars, and then slowly fizzle away until a small white dwarf is remaining. But if someone were to, in fact, blow up the sun with this amount of power, then, well, we would all be dust.
Yeah.
That's awesome. All right. I think that was awesome. Thank you. Well done. Those of you that want to keep going, you're going to have to go buy it, all right? So we're going to take a 5-minute break or so while we set up for the main meeting. I know some of you will probably need the facilities, and we'll